Welcome everyone to a case study of batch processing with Spring Cloud Dataflow Server in Cloud Foundry. Thanks for making it to the last session of the day, especially when it's up against Jürgen Holler's speech this afternoon. Today I'll be presenting some lessons learned by my team while we were performing an application replatforming exercise. We'll cover some introductory information, then we'll talk about the problem that we faced, the process we faced to get through it, lessons learned, and lastly, we'll do a live demo. So my name is Bruce Thelen. I'm a principal software architect at CoreLogic. I'm in the Innovation Labs department. CoreLogic's vision is to deliver unique property-level insights that power the global real estate economy. CoreLogic's currently in the middle of a cloud-native transformation that started about 4 years ago, right across the street at Pivotal Labs. That was our first exposure to PCF and to the Pivotal XP process, and we've kept up with it ever since. Our group does new product development, porting existing apps onto the cloud, renewing old products, that kind of stuff. The particular product we were working on in the product line that spawned this talk was called CoreLogic RiskMeter. It is a product for insurance underwriters to gauge natural hazard risks against some of CoreLogic's proprietary hazard analytics, such as wildfire risk, flooding risk. Wildfire is especially pertinent today given what's going on down in LA. The legacy version of RiskMeter is about 20 years old. It runs on VB.NET, VB6, ASP Classic, so it really was time for a technology refresh. And enter the team that I work with to provide that technology refresh. It is a web application, is now implemented as a web application and an API in Angular on the front end and a mostly monolithic back end written in Spring Boot. It's deployed Cloud Foundry, it's zero downtime deployed, it's very stateless, very easy to operate. To put some context around what the product looks like, this is the workflow. The underwriter logs in. They've got a screen that allows them to search for a property. Once they've located that property, they choose the analytics that they'd like to relate it against, depending on what they're going to insure the property against. And then they submit it, and they're given the scores that they've ordered. You can see here that this one is a flood risk score of 10. It's got a wildfire risk score of 6. They've got this mapping component built on Google Maps and some proprietary CoreLogic systems to draw, for instance, those flood polygons that are shown in relation to the Google map on the nice slippy map. It's a modern interface that works really well. While we were executing this replatforming, the team came up against the need to do batch orders. Because imagine if you are an underwriter and you've got 500 or 1,000 properties or even 5,000 properties to relate. Typing them in one at a time on that UI is just not going to cut it. Not only was that feature in the legacy app, the logs showed that it was well used, and all user interviews surfaced that the users felt it was a very vital part of their workflow for things like reinsurance decisions or writing multiple location policies. So we knew that we had to go ahead and take on such a feature in the new system. We had a couple design principles that we wanted to follow in order to do the new version of the batch system. We wanted it to fit our cloud native approach. We wanted it to be easy. We wanted the batches to be resilient. We wanted them to not block software pushes, and we didn't want to interrupt a batch with a software push. So we really wanted that to be, those two things to be nice and separate. So at this point, our group had really just been doing web apps, APIs, stateless APIs, hadn't done anything like this, so it was relatively new territory for us. We took that, our designers had that idea in mind. They said, okay, well, let's see what a workflow might look like for this batch processing, and they came up with this. Choose your products, you upload an input file, the system takes over, verifies that input file, processes those analytics that you've chosen, and then gives you a file for download. No problem. Then they came up with the screens. that support it. So the first screen, this is the batch status page. Once you click that Start New Batch, you're prompted to choose those analytics. This one has city, flood risk score, and wildfire risk score. Once you chose those analytics, it prompts you to update your, upload your file. You can use the drag target, the drop target, or you can use a file chooser. Then you can name your output, and then you're sent back to that status screen with this nice real-time updating progress bar. So once it's done, you're provided a link to download the file. So that easy. We knew these features that we needed to implement, and we had to pick some technology to use to implement those features. At first, we knew that Spring Boot and Cloud Foundry were going to be givens, given that Cloud Foundry is our platform of choice, and we've been doing the back end to this point in Spring Boot, so it's a good starting place. That heavy investment in Spring and Cloud Foundry led us to Spring Batch, which provides a mechanism for composing steps to make repeatable bulk processing jobs. It's exactly what we needed to do. That seems like it was all in alignment thus far. But we knew that adding Spring Batch to our mostly monolithic backend as is was not going to meet our design principles. What was going to happen is those long-running batches would either block our ability to push new code, or we would have to interrupt the batch to push the new code, and neither was desirable. We just wanted to say, here's our code, run it for me. I don't care how. We didn't want to have to care so much about how. So we wanted to keep it on Cloud Foundry in Spring, but out of process. That led us to, our research then led to Dataflow Server. Dataflow Server, it deploys pipelines into modern runtimes like Cloud Foundry, Apache Mesos, Apache Yarn, and given that Cloud Foundry was our target, it fit well. It uses Spring Cloud Tasks or Spring Cloud Streams in order to actually execute the processes. So we reviewed both Spring Cloud Stream and Spring Cloud Tasks, and we said, now, which of these should be executing our batch for us? After some reading, it was apparent that streams are long-running events that are basically going to live forever, and then you're going to process an event when a message appears or something like that. But a task is a finite-lived process. Here's my input, do something with it, give me my output, you can tear down, I don't need you running all the time. So we chose the Spring Cloud Task route, and that is what we would wrap our batch with in order to run it from the Spring Cloud Dataflow Server. Spring Cloud Dataflow Server does this work through the Spring Cloud Deployer. And that Spring Cloud Deployer is a Spring component that knows how to talk to these different platforms like Yarn, Mesos, and Cloud Foundry, and knows how to instruct it to run a Spring Batch or Spring Boot application. The mechanism by which this happens on Cloud Foundry is actually called a Cloud Foundry task. Cloud Foundry task is different than a regular application, like a web application that you're going to run on Cloud Foundry, because tasks is a short running process. It's going to run in its own container. When that process is done and the Spring context tears down, Cloud Foundry is going to go ahead and throw away that container for you. It's not going to keep it up forever and worry about keeping it up forever and doing health checks on it when it doesn't care that it's running any longer. That feature is experimental in 1.7 and 1.8, and then first class in 1.9 and above. We were on 1.9 at the time. We're better than that now, but it was available to us, so it worked out well. We knew that in order to do this work, we were going to have to start decomposing that mostly monolithic backend. So this is the process we went through to actually implement this. So when we talk about these different maturity levels of decomposition, we usually use the terminology from this site, appcontinuum.io. And I realized that it doesn't actually have the words on it, just the symbols. But this one here at the beginning The one hexagon there is a single application. The next level of maturity is a single application with namespaces. Think of that as a Java application that's still a monolith, but has a well thought out package structure. The next is single application and components, which is a single monolithic application, but it may have code modules that are already compiled into jars from that module, but they go into the single app. Nextly, there is the multiple applications and components, and that's the one with the blue, gray, and green there. And you actually have multiple applications at this point. They may share or they may have their own set of components, but they're all still in process, built basically two different apps now, or 3 different apps, or however many you need. That's when you're starting to pull it out into different apps. And then lastly, there's multiple applications, components, and services. So we had to choose, we had to first orient where we are on this spectrum, and we felt we were really at the single application with namespaces section, but we wanted to move 2 places to the right to multiple applications and components. We didn't go all the way to multiple applications, components, and services, simply because we were a little bit afraid of going too far and falling into somewhat of a distributed monolith. So we decided to go ahead and get to the multiple applications and components and defer any decisions to decompose and add additional remoting of services to make sure that we had all of our ducks in a row. We're fully prepared to decompose to more microservices as someone needs to access one of our domain objects. We're ready to do that, but we didn't feel it was necessary for the task at hand. So we started on it. We had this single application as a monolith, and the first thing we did was not break it apart. The first thing we did was implement our feature, because we felt that it would be easier to break apart once we had the batch processing feature. So we didn't do any theoretical, this is where it's going to be. We just made sure that we kept a nice clean namespacing, and then we implemented the feature in place. We feature flagged it off so that we could continue to work on master without any needs to keep a feature branch rebasing daily or anything like that, or have any complex, difficult merges at the end of implementation. And then we started putting Spring Batch in there. Add the starter, put in the enable batch processing annotation, create the configuration which composes the steps necessary to run the batch, which is basically read input file, process rows in file, write output file. It was pretty much that simple. Then we had to start talking about how to make that nice progress bar dance. And that was another set of effort that we did. We didn't even make the progress bar right away. We were dog fooding this on prod the whole time when it was in the monolith to make sure that it was running how we wanted, how we expected. It was feature flagged off, so we turned it on all of our dev accounts. We went in, we were running it every time we pushed, made sure it was still working properly. Then we worked on the progress bar. We figured WebSockets was the obvious way to do that progress bar. We brought in the AMQP starter, the WebSocket starter on our back end. We registered the Stomp endpoint. We bound to RabbitMQ service in Cloud Foundry. And then for our front end, we found a very nice ng2-stomp.js component, which is very nice for doing WebSockets in Angular 2+. And we made it work inline, and it worked all great. Then we started to do the decomposition. So in order to decompose it, we took the monolith and we started breaking it down into basically 3 pieces. That was our web component, which was going to be the fat jar that you're going to boot repackage in order to CF push it into your Cloud Foundry. And it includes REST controllers, configurations that are specific to the running on the web, et cetera. Anything and any domain objects that were specific to the web and not necessary for the batch processing. Then we took the batch and made a code module that compiled into its own jar, which now the web depends on. And it is basically the code that has the composition of the batch job and the add enable batch processing annotation all goes there, and then the code to iterate through the definition of each of the steps that are part of the batch job. And then we had a shared jar that both of these two depend on. So now we had a way to start making new applications. And our third step was to take those applications and break them out. The first thing we did was take the Dataflow server. Dataflow server is just a Spring Boot app, so that was quite simple to just CF push out with our normal blue-green pipeline into our Cloud Foundry instance. And then we wrote the build for the batch to be its own separate boot application that is basically it is a Spring Boot command line runner at this point. And then the web is the Spring Boot fat jar that has Spring MVC and all the REST controllers. They both pull in the same shared jar, which is the domain logic to produce the analytics. Some is to produce the analytics, and some is to call external services that produce the analytics. Slight distinction, but in either case, that becomes shared. Again, this batch application also has add enable task on it, that annotation, and it depends on the Spring Cloud task starter, so that it can be a Spring Cloud task that runs the batch. So the solution then looked like this from an architectural standpoint. We have a RiskMeter Angular 5 single-page web app that makes REST calls to the web backend, which is a Spring Boot application running in Cloud Foundry. When a batch needs to run, it writes the input file into S3, which is actually not Amazon S3. It is an S3 appliance, an EMC ECS in our data center. And then it makes a REST call to the Dataflow server, instructing that Dataflow server to kick off the batch and to give that batch the configuration that it needs to be able to run. Then the Dataflow server says, I know that task, no problem. I'm going to call Cloud Foundry's API to instruct Cloud Foundry to run that app on the cloud. So that's how it runs it on the cloud for us. Then that batch runs, there's a StepExecutionListener that executes on every line of the batch that pushes down into the RabbitMQ, the progress in terms of percentage. And then in our web application, we have our reader that reads the RabbitMQ and pushes that data out over Stomp via WebSockets. So that's how it all looks from an architectural standpoint. I'll talk about the lessons that we learned along here and how those influenced some of the decisions we made. Three main categories: deployment, passing data between those two systems, and injecting configuration into those systems. Those are the three main lessons learned. First, as it pertains to deployment, the Dataflow server is not actually responsible for storing that task that you want to run. It doesn't store that Spring Boot jar. What it stores is a reference to it. So it knows three different ways to find these. It knows a Maven URL, an HTTP URL, or a fully qualified path name on a local file system. Obviously, local file systems are not even in the conversation for any kind of cloud prod deployments. So it's either Maven URL or HTTP URL. We chose Maven. We've already got Nexus repo. We're already pushing the jars there. It seems like a very convenient way to provide that reference. You can use three different ways to do that registration, or four different ways to do that registration. There's the GUI as shown here, probably not relevant for production automated deployments. You have a shell that you can start up, connect to, and then run commands against your Dataflow server, such as app register and task definition, etc. You have a REST API, which here's a curl against that REST API. Or you have a pre-built Java client. Given that we're already doing our blue-green deploy pipeline is implemented as a Jenkins file, which shells out to bash scripts, we found the REST API the easiest to deal with because you've got curl and it's quite simple to hook into one of the phases that we already have. So we had to then blue-green it. So this is what our original blue-green deployment looked like when we had only a web app. Deploy new web app, smoke test new web app. That was a manual step that our PM would do. He just felt more comfortable. Even though it was a push button deployment, he wanted it to pause so he can go and kick the tires. And just to be comfortable, he never spends more than about 5 minutes on it. It's really more of a safety blanket than anything. Then you reroute the traffic whenever he tells the pipeline to continue. It reroutes traffic to the new, and then it stops the old one. Very simple blue-green pipeline. Now that we have more than one application to deploy, and we have to do this registration phase, our pipeline got a bit more complex with no words on it. Oh, there it is. Okay, great. So now this is what our pipeline looks like. You deploy the new web app, then the script runs that registers the new version of the batch, and then right here you smoke test the web and the batch. I know they're in sequence, but they're actually done in parallel. Then reroute the web traffic to the new web once those both are done, stop the old web app, and then clean up any completed batches, tasks that you have hanging out on Cloud Foundry. I'll go over smoke testing and that cleanup in a little more detail at this point. So smoke testing the web front end, we already have that process. Our PM is fine with it. We didn't want to add a manual step to it to tell him, now go and run a batch. That was just one of those things that's bound to get forgotten the one time it's broken. So we didn't even want to make that a possibility. So what we did was we said, what do we need to test on that batch to be comfortable? The software has been TDD'd top to bottom. It's got 3 different levels of testing. It's got the unit, it's got some integrations, and it's got some end-to-ends that run in mock mode. So we're really feeling comfortable that software looks good, but when you push, you have a software, a built artifact, and you have a set of configurations. What we really wanted to do is test those configurations to make sure that the Spring context would load the first time someone tries to run a batch. So we made sure that all the Spring properties that we're injecting from the externalized configuration were appropriately annotated as not nulls, and then we run basically an empty batch. And if that empty batch succeeds and the Spring context loads, that is done. And it should be good to go to the next phase of the pipeline. Cleaning up any completed batch. What happened was, the first time we did it a couple times, we're deploying with different names. Each of the different versions of the task is named with the version. So our operators said, what's all this junking up our Cloud Foundry with different, it's hard to see, but each of those is named RiskMeter, batch, app, a gitshaw-task. And they're like, why do we have all these hanging out? We're like, oh, Cloud Foundry doesn't actually delete the app, so we have to clean up after it. Sure, it throws away the containers that have been used for that runtime, but it keeps the app definition there. So in order to see what has completed, and this one gets a little hard to see, you run a CF tasks command. It enumerates all the different times that the task is run and the status that has occurred at that point. So we implemented that as a script at the very end. Passing data between the web and the batch. So really all you need to pass from the web tier to the batch is enough to fill this batch job parameters in the job launcher.run. And all we really needed was input file, user it's for, and list of the different products that they're trying to order. So we took a kind of a database messaging approach, which is not the greatest, I know, but we're prepared to refactor that at any time. We push the configuration into a table, run the batch with the ID from the table, and then when the batch gets that ID, it hydrates the configuration from the database. Fully prepared to refactor that as soon as it bites us. And here is basically what the code that calls the data flow server to instruct it to start the batch looks like. It's basically an async REST template is just going to post this post body. It's got a name, which is the task that you're going to run, and it's got arguments. Whatever is inside of that arguments is actually going to get passed to the command line runner as the command line arguments. So this is your location to pass any kind of instructions to the data, to the actual task that's going to run. Note that this is an async REST template. We did that because remember that the jar to execute is not actually stored in the data flow server. It's just a reference. So the data flow server will block until it pulls that artifact down from HTTP or Maven. Therefore, your kind of user experience is going to be degraded. And we chose to async it and then care about the status later. Here's what it looks like as a curl. And this is basically what we do for our smoke test, is we put a curl to say, hey, Dataflow server, start an empty batch. Lastly, injecting configuration. So at this point, you now have 3 times the number of applications that you need to configure. And that's a 3x increase in your configuration overload and overhead. So in a PCF deployed Spring Boot app, you basically are going to configure 2 things: your container, usually via manifest, and your application via whatever means you felt appropriate from Spring Boot's 17 layers of externalized configuration. We had actually chosen to combine those into one file and say, look, the manifest, we're just going to set all these environment variables here. And that way we have one file that's going to do both. Because we were having some feelings of kind of YAGME or you ain't going to need it over Spring Cloud config server. But once we had 3 applications times 6 PCF spaces worth, and then the manifests got basically a lot of duplication and it got very long, we all of a sudden felt we do need it. And we had luckily just about 2 weeks prior to starting this work had moved to config server, and that really saved us some time in the end. But this effort probably would have forced us to go there. So a little quick point about this piece of YAML here, and here's a definite gotcha. So this is the Spring Cloud Dataflow server's YAML file, and it is giving the Spring Cloud deployer the instructions it needs. This is your Cloud Foundry section that says, here's your domain, here's your API URL, here's how you get to Cloud Foundry. And then this task section here says, hey, this is the build pack to use. These are the services to bind to. This is your memory setting, this is your disk quote, et cetera, because you can't use a manifest. The Spring Cloud Dataflow server doesn't know how to give a manifest to run it. So it uses this means to do it. One thing it won't let you set here also is environment variables. So, and if I look through Spring Cloud Deployer top to bottom, if I'm wrong on that, please tweet me and correct me, because that was definitely a pain point for us. Let's go ahead and do a quick demo, and I hope that I can get this done in less than the 2 minutes we have left. So here is RiskMeter. I will go ahead and log in. And I'm an administrator, so it immediately takes me to the administrator screen. But here is the normal user entry point. I will say I'm going to start a new batch. Really, all I care about is something quick, counties. I'll upload a small file here, 100 rows, and I'll call this like a fast food restaurants, TAURENTS, and then I'll hit go. So now it has instructed the Spring Cloud Dataflow server to run the batch. Notice that it's in queue. It's going to stay in queue until the Spring Cloud context has come up, because this is basically CF pushing an app, and it is trying to start. So it hasn't had enough information to update any status yet to tell me the progress of where it is. So the quicker your Spring Boot app starts, the quicker that in queue goes away, and the quicker that progress bar starts moving. And I'm expecting it to start moving any second now. That is also one of the reasons we did the async REST template. This phase would get quite long if something, it had to download that from the Maven repo. It would just be a bad user experience. Also, the smoke test precedes that cache, so it makes it a little bit quicker if you're on the instance that particular one having to run. So there we are, our batch is running. I'm gonna go ahead and swap back to PowerPoint and let it, while it runs out, because we are at the end of the day and I'm sure everyone is ready to get to the Hub Social. So in conclusion, our previous CoreLogic projects who have had to do things like this really had to rely on complex infrastructure provisioning and homegrown thread control or anything like that. We brought in Spring Batch. We used Cloud Foundry. We were able to knock that feature out in literally less than 2 months. Thank you.